Welcome. My name's Johnny Devine. I'm a nationally board certified teacher in Tacoma, Washington. For the past couple of years, I've been using the project-based Knowledge and Action curriculum for my AP Physics 1 classes. In this video, I'll share insights and tips about the student products of the Art in Motion project. In this project, students assume the role of an artist, utilizing their knowledge of DC electricity, springs, pendulums, and wave behavior to create engaging kinematic sculptures. Early in the project, students are introduced to important design concepts and a number of case studies to help them focus their ideas. Before actual construction of the sculptures begins, though, students complete a series of investigations to introduce them to the critical physics knowledge. First, students explore pendulums and are introduced to important concepts about simple harmonic motion, such as period and frequency. Through experimentation, they determine what variables affect the period. Concepts of energy and its conservation are looped back in, making connections to the Mission to Mars project. Students continue their exploration of harmonic motion by investigating a mass on a spring, again determining what variables affect its period. Students also model the position of the mass versus time with a sine wave. Next, students extend their understanding of harmonic motion to waves in general, both longitudinal and transverse. Students quickly arrive at important concepts of reflection, superposition, and resonance. This is explored concretely with the use of sound waves generated with tuning forks inside of PVC pipes. Lastly, students explore all the important concepts of DC circuits, including the behavior of current, voltage, power, and resistance in series and parallel circuits. Kirchhoff's rules are used to analyze complex arrangements of basic electrical components. Throughout all of these investigations, students are prompted to reflect and brainstorm ways to connect each concept to their final sculpture. By the time construction begins, students have a pretty good idea of what they plan to construct. In my class, sculptures have ranged from simple to complex, including this fan, wired to turn itself on and off perpetually. In this example, a student made a musical machine that could be played by adjusting tension on the guitar string with a clothespin. I've had students with access to our makerspace create elaborate sculptures that include the use of CNC machines and elaborate gearing. I've also had some of my smartest students create surprisingly simple yet engaging sculptures, such as the double pendulum. I've found this project provides a unique opportunity for a different type of student to show their skill and creativity. As with any construction, safety is paramount. Encourage safe use of tools at all times. Cost of materials can be a hurdle to overcome, so encourage students early in the project to be bringing in resources they could use or share, such as old broken toys that contain motors. Beyond having basic cutting tools on hand, I try to have a supply of hot glue sticks, cardboard, and batteries handy. At the end of the project, students exhibit their whimsical kinetic sculptures for the public. Rather than an evaluation of students' physics knowledge, this event is meant to be a celebration of the art, evoking surprise, laughter, and awe from the viewers. The final presentation of the sculptures can be in class and judged by a panel of students, teachers, and community members. Or you could have students present their work digitally by describing their construction on a website like Instructables. Since most of the construction of the sculptures occurs after the test in May, there's lots of ways you could choose to end the year on this fun project.